It's all good.
All right, good to go.
Okay, hello, I'm here with Maggie, and we are talking about the magnetic fields of the Earth. So these things are completely invisible. How do we even know that they're real?
So there are observations we can make of the field. For example, we use compasses, and also anytime you see, or when people see the northern lights, that's, the light you're seeing is like a tracer of the magnetic field being pushed by solar winds.
And it's my understanding that we still, even though we can see evidence of it, we understand very little about it.
Yeah. So to make observations of the field further back in time than we've just been making measurements of it, you have to go to the rock record. And so you have to find rocks from specific times and specific places, and there's fairly sparse data. So we don't know very well what the field has done back in time.
And so how do you find these rocks?
You can use lots of igneous rocks on land, but in the Earth's seafloor, there's like kind of a perfect natural laboratory where there's two tectonic plates moving apart. It creates these long chains of volcanoes that erupt very, very frequently. So as new material is erupted, as that rock is hot and newly formed, it records the magnetic field at that time, and then it moves away from the ridge. And so you end up with a time series of the field behavior back in time.
And it's showing different strengths of the field?
Yeah. So in the seafloor record, we see periodic field reversals. So where the pole, we're used to the North Pole being at the North Pole, but every once in a while it flips, and the South Pole is the North Pole. And so then in between those reversals, there's also changes in intensity. And so like what that would mean for us, when the intensity is lower, more cosmic radiation gets in, and so it's bad for human beings. It gives us more incidence of cancer, but also you would be able to see like the northern lights down here in San Diego.
But
possibly.
That hasn't happened.
In our lifetimes. I mean, that's the thing, it's geologic time. It goes back millions and millions of years, not just human time.
How would when the poles reverse, has that ever happened in human history?
No, so the last magnetic field reversal was 760,000 years ago. So there were animals around, like these magnetic field reversals don't cause mass extinctions, but there weren't human beings, there wasn't a whole electrical grid and satellites in space, so those things would be impacted if a reversal happened.
So are you saying that birds, like when they used to fly north, they actually used to fly south, like before the reversal?
I mean, they would still be using the magnetic field as a reference frame, so they could still get where they were going. It's just like how that was in relation to what was on the ground would be different.
Would that happen in like an instant, or does it take?
It takes, we don't know for sure, but we think about 1,000 years for it to reverse. So even then, like multiple human lifetimes while this thing is happening.
Wow. So is your research concerned with the potential magnetic apocalypse, or what are you?
So I study more than reversals, changes in the intensity, and what we've been finding is instead of just bouncing around like a random process, it grows quickly and then decays slowly, and we think that's related to two different processes in the outer core. And so, if we learned how that behaves really well, for example, for the last 200 years, the field's intensity has been decreasing. So if we knew really well what happened in the past, we could tell you what's going to happen in the future.
Cool. Thank you.
Yeah.